switch them all to sines and cosines. You're going to switch these ones to sines and cosines. So sin x will stay sin x. Cotan x will switch to, not 1 over tan, cotan x will switch to cos x over sin x. And then cos x will stay cos x over 1. Put them together. Just switch them, at the very least.
Are cotan and cos multiplying?
Yes, they are.
Huh? Okay, sure.
Yeah. That's what she's confused me about.
Rehashing it again. All right. What I do if I have a fraction multiplied by something that's not a fraction, I'll make it a fraction. So what is cos x over?
1.
It's over 1. So now I know I have, at the very least, sin x over 1 plus, what's this become? What will this become?
Cos over sin.
Cos squared x over sin x.
Why? Oh, yeah.
Because the cos times the cos. Okay. Cotan is cos x over sin x on your formula sheet. So all we did was we replaced cotan x with cos x over sin x because it's on the formula sheet. We could replace it with 1 over tan x, but that's not as helpful for these. You try and switch it to as many coses and sines as possible. Now I have sin x over 1 plus cos squared x over sin x. Can I add them? No. In order to add fractions, you need what? A common denominator. This one is a 1. This one is a sin x. So all I have to do is to the left side multiply it by what? Sin x. Sin x on the top, sin x on the bottom. So I'm technically going to get sine times sine, which is sine squared x over sin x plus cos squared x over sin x. Now what can I do? Once you have a common denominator, you can write your whole numerators over one denominator, right? So we're going to get sine squared x plus cos squared x over sin x. Do we have anything on our formula sheet that we could replace here? We were talking about Pythagorean theorem identities. That might be where my face goes. So look on the left side.
Could you simplify it? Like, I'm not sure.
Yep.
This sin x, it can just make it sin x plus cos x squared.
Nope. So these are attached by a plus sign. So when they're attached by a plus sign, I'll force a bracket around them so that you know that you can't cross them off. So it's like rationals last year. When you had like an x plus 3 over an x, you couldn't cross the x's off because the x plus 3 are sewn together with a plus sign, correct?
Okay.
Right now, the sine squared x and the cos squared x are sewn together with a plus sign. So if there's ever a plus sign or a minus sign between two terms, I just bracket them because they're stuck together. It's like the plus or the minus sign is two-sided tape, and those things are stuck together. So I can't like cross this sine squared, this squared off with this sign because this is one term. The plus or minus sign are two-sided tape and they're squishing them together. Okay, so I can't do that. But I can go to my formula sheet, and sine squared x plus cos squared x equals 1. It says that, right? Sine squared x plus cos squared x equals 1. We know that because that's just the unit circle formula, right? So instead of writing sine squared x plus cos squared x, I could turn that into a really big 1. So now I have 1 over sine x, which is cosecant x, even on our formula sheet. Done.
That's kind of cool.
It is kind of cool.
No.
No.
There's so much work for no reason.
Okay. What I want you to do is type this into y1. Now, how do I type a cotan into your calculator? If I'm stuck, I can go to my formula sheet. Cotan is just 1 over, 1 over tan. So if I'm going to go type it into my calculator, I can go it was sine x plus, and then I can go sine x, that is not what I want, sine x plus, and then alpha y equals enter is what I'm going to use. 1 over tan x, arrow up. And what's the last one? Cos? Times cos x.
Mine doesn't even show up on the graph.
Patience, grasshopper. Patience. You could just go 1 over tan x in brackets. So I'll show you what I could do. I could go sine x plus 1 divided by tan x in brackets times cos x in brackets, right? No big deal. I'm going to go zoom trig and hope to goodness something shows up. Zoom trig.
Oh.
So I got something. It's kind of cray-cray. What you don't know is that's actually the cosecant graph. Go into your y2. And now I'm going to put my answer. My answer is what? Cosecant. I don't know how to type cosecant. I got no idea. There's no button for cosecant. Oh, I have this formula sheet. It's so useful. It's 1 divided by, it tells me how to type it. Isn't that amazing? And you got it for the price of nothing. Free. Isn't that a gift? Free. So we're going to go 1 divided by sine x. Isn't that pretty? Did you do that? So, this is what you're going to do if you are not with a colored calculator. You're going to go over to your Y2. Remember I told you to come, you go over here and you hit enter once on that flash so it makes it thicker so you can actually see it drawing over top of the other one. If not, you might be like, oh, there's no other graph. It's drawing on top, but it's actually drawing way up here or down here and you just assuming it's drawn on top of it. So if you go over to your Y2 over here over to the slash and you hit enter once, it'll make it thicker. So what it'll do is it'll draw a thin line and then it'll draw a thicker one over top of it and then you actually know it drew it over top. Yeah? So you should feel a little more confident that you didn't suck. Okay? A little more confident. Now, if you look at the blue one itself, I'm just going to show you. So look at what I have here. It actually drew over each of these spots, didn't it? But if you go to the graph, if I take the red out, the blue one actually had gaps. Why is there gaps? Because you have a denominator with a variable here. So you have non-permissible values. You actually do have them on the cosecant graph too, but you have extras because of having that sign. Okay, we're going to try example 2. Looks a little more advanced. Well, it's a fraction over fractions. So cotan is what? What's cotan? Cos x over, it is over tan, but I'm going to do cos and sines instead. So cos x over sine x. And then I'm immediately going to, I'm going to start stacking a fraction over a fraction. When that starts happening for you, stop. Write them sideways. So I have a fraction and then I'm going to go do another fraction on the bottom. Instead, go numerator in brackets divided by denominator in brackets. Write them sideways. Don't stack fractions. Fraction divided by fraction sideways. Okay? So I have cosecant. What's cosecant?
1 over.
Yep. 1 over sine. Cosecant is 1 over sine minus sine. Theta over 1, technically. We agree? Pencils down, brains used. Because if you can't get this concept, you will get every freaking trig one wrong and you'll be sad. Sad people. Sad. Pencils down, paying attention even if you're in the middle of something. Okay. The rule with fractions and division is you're allowed to flip the right-hand side and multiply. We agree? Flip right-hand side and multiply. You are actually only allowed to do that if you have a full fraction divided by a full fraction. So what does that mean? That means I have a fraction. Numerator over denominator, whole thing, divided by numerator over denominator, whole thing. We agree? Do I currently have that? No. If you know this rule, life will be so much better. Right now, I do not have that. Can I flip this side? No. I can only flip the right-hand side if I have a whole fraction divided by a whole fraction. I don't got that.
You can get it.
But I can get that, though. How do I do that? Ooh. Let me, tell me.
So you gotta get a common denominator, so you square the sine over 1.
So you're going to multiply this one by sine theta over sine theta,
Yeah.
is what you're saying.
True. And
True. And then we're going to get, this is going to stay.
1 minus sine squared x divided by sine x.
Yes. So we're going to get 1 minus sine squared x now. Or sine squared, why am I have x's and thetas? I'm all over the map. Theta, 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 over sine theta. Now, with all the brain power we just learned, now am I allowed to flip it?
Yep.
Do I have a full fraction, numerator over denominator, divided by full fraction, numerator over denominator? Yep. Numerator over denominator, divided by numerator over denominator. Now I can flip it. If you know that rule, your life will be so much better. I promise you. So we're going to get cos theta over sine theta times, so I can just put a bracket by a bracket, right? Sine theta over 1 minus sine squared theta. So I can technically put these together. And I can get cos theta sine theta. And they can go in their own brackets. Why can they go in their own brackets? Because they are not added. Is there an addition or subtraction sign between those two? Is there an addition or subtraction sign between them? No. Addition or subtraction sign between makes two-sided tape brackets outside, correct? But this is just multiplied. When something's multiplied by something, brackets can just touch each other, right? We know that. Okay, and then on the bottom, we have sine theta, and then 1 minus sine squared theta.
So would it be sine theta minus sine theta cubed?
No, don't do that. I have a sine theta on the top and a sine theta on the bottom in brackets. What can I do then? They can go away. Bye-bye. See you later. Nice seeing you. It's been a great time talking to you. Okay? Because they're in their own brackets and they match. They're like little twins. If you have a twin on the top and a twin on the bottom, they can become twin friends and go away. Get out of my life. Have fun, but go away. All right. Now I have cos theta on the top. There's nothing I can do with that. But remember all the variations. We had variations of the Pythagorean theorem. We had variations. We had sine theta plus cos theta equals 1. That's right off my formula sheet. Yes. Yes. Mm-hmm. So we had variations. I'm going to do it on the board over here so no one can see it. So that's people at home. I have sine squared theta plus cos squared theta equals 1. I currently have 1 minus sine squared theta. So if I move that over, I get one of the variations, don't I? I can just subtract the sine squared over to the 1. And now I have cos squared theta equals 1 minus sine squared, doesn't it? What's on the bottom of that bad boy? 1 minus sine squared. So what can I change it with? Cos squared. Did I tell you that it is way more important to know what's on your formula sheet or else you get stuck? Yeah, people who know what's on there will not get stuck. People who have no clue will get stuck. So this is cos squared theta. So cos squared theta is just the same as writing cos squared or cos times cos, correct? That's what cos squared theta is, right? So I can take one of these coses off for the other one when it's just by itself. If this was attached to a +1, I wouldn't be able to do it. Like right here, I have 1 minus sine squared. If I had a sign on the top, I wouldn't be able to cancel them because these are attached. So this squared and this cos cancel. What happens when your numerator cancels off? You're left with a 1. So we're left with 1 over cos theta, which is the same as secant. Could I check these? Could I type that into y1, type that into y2, and hope they look the same? Yeah.
Can you just remind me again when the cos squared theta is coming on the bottom of the denominator?
So I replaced this with cos squared theta. This here with this from the Pythagorean theorem identity moved around. So I just subtract the sine squared over, and then cos squared theta equals 1 minus sine.
Oh, yeah, I see that.
Oh my gosh, man.
Okay, try one.
I think I popped it.
What is this supposed to be? Over cos squared. So now we're ready to now switch it. Wait, isn't it sine? Huh? Where are you gonna sign? Sign can come in.
1 over sine
You
is...
should have sine theta over cos theta divided by sine squared theta over cos theta.
What? Where did you get the sign?
Yeah, that's actually quite easy, to be honest.
I think it works. Now,
And then just like you have this big one.
Yeah.
Single one, yeah.
oh, you were so wrong. That's not the problem.
Okay, let's see where we're at. So we're going to do sine over cos. Shh. And then you do 1 over cos minus cos, make a common denominator, very similar to the previous one. Then we can flip because we have full fraction over full fraction, so I'm going to get sine theta cos theta times cos theta over 1 minus cos squared theta. Because these are multiplied, these can actually cancel, right? Boom, 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 boom. So I'm going to get sine theta. What's 1 minus cos squared?
Sine squared.
It's just moving the cos squared over this time, so it's sine squared theta. Then the sine and the squared cancel, and I'm left with 1 over sine theta, which is cosecant. So here we have sine squared theta, or in this case sine squared u, over 1 technically. What's 1 plus cotan squared theta? Can I replace it with anything? Is there such a thing? What's 1 plus cotan squared theta? There's a formula on your formula sheet that says 1 plus cotan squared u equals cosecant squared u. Isn't there?
Where was this formula made?
In the Pythagorean theorem identities. There's 3 of them. We went over them yesterday. Do you see how if you know what's on your formula sheet, life is easy? If you don't, life is rough. The u is the x or the theta.
You're just putting in different letters together.
Just putting in different letters. Okay. So the 1 plus cotan u squared u can be replaced with bracket cosecant squared u. So I can literally take the 1 plus cotan squared, toss it behind my head, and throw in the cos squared u, because it's the same thing, cosecant squared u. Now, the sine squared u still stays, because I don't know what I can do with that. But cosecant is the same as what?
1 over sine.
So this is something to note. At the top of your formula sheet, you have single ones. So at the top of your formula sheet, you have tan theta equals sine theta over cos theta. Well, you could take tan squared theta and replace it with sine squared over cos. So these ones at the top can actually be replaced with squared ones as well. So for example, cosecant squared u I can replace cosecant u with 1 over sine. So I can replace cosecant squared u with 1 over sine squared u. Because cosecant, I'm going to show this over here, cosecant squared u is the same as saying cosecant u times cosecant u, isn't it? So I can go 1 over sine u times 1 over sine u, which is actually the same as 1 over sine squared u. So that's why the single ones, cosecant u is the same as 1 over sine u, cosecant squared u is the same as 1 over sine squared u. I can just replace. Geez, just a little life ruining there. You really do. You go to the movies and you just like, you know, Lassie dies or something. That's what you do. You scratch off and you're left with a 1. Do the try.
Huh?
Cotan squared theta is the same as cos theta over sine theta. And I know cos squared minus 1 I can replace. Because I just have to figure out a way to rearrange this bad boy to be cos squared minus 1. So I need the 1 to be minus. It's currently positive, correct? So I have sine squared theta plus cos squared theta equals 1. I need it to be a minus 1, so I need to move that bad boy over. So I'm going to get sine squared theta plus cos squared theta minus 1 equals 0. Then I need this to be by itself. So what's am I going to have to do?
Minus the sine.
Minus that sine over. So cos squared theta minus 1 equals negative sine squared theta. So now I need to replace this with that. Take cos squared theta minus 1, toss it behind my head, and replace it with negative sine squared theta over 1.
Negative cos squared over 1.
Then the sine squared, one of the sines can cancel, and then I'm just left with negative sine theta cos theta.
Hold on.
Oh, it's a squared. I'm going back to where I was doing stuff because I forgot to put the squared.
I was like, whoa, whoa, whoa.
Like, it needs to be prettier. Boom! So it's just negative cos squared. Oh, so much prettier. Jeez. And how would I have caught myself? I would have put the original into my y1. I would have put my answer into y2, and the bad boy wouldn't have matched. So I've been like, go back, try again. Squared. So these have to be cos squared over sine squared. Yeah.
See, everyone makes mistakes.
True. My daughter says that if you make mistakes, that's the only way you learn. She's in grade 2, and she's just like a walking happy slogan. That's what she is. Okay. She's like a 2-glass full girl. That's what she is. Not 1. She's a 2.
All right, let's simplify more of these.
Here it says simplify each expression to one of the 3 primary trig ratios. So it needs to be sine, cos, or tan. Okay? So secant is what? Secant squared x is what? 1 over cos squared x. We agree?
No, I disagree.
Well, it is. And then we're going to times that by cos x over 1. You see that? That's my numerator. I'm going to put it in a big bracket. And then I'm going to have it stacked of a fraction, but I'm like, no. Lepp said I do not stack fractions. Do not stack fractions, I am. Do not stack fractions, Sam. I don't know. Anyways, divide. I have a hair. I'm like just ADD'd real hard right there. But anyways, cosecant is what? 1 over sine. Yes. When they're singles, you don't even have an option. When they're singles, you got to go to the top and pull from the top. That's all you got. When you have squares, you have Pythagorean theorem identities you can choose from. When they're singles, you got the top. That's it. So when you see singles, you'll probably be happy because you have only these little options. When you have squares, you could use the singles or the squares. Okay? All right. So this squared, because this is they're both touching by brackets, this squared can cross off that cos. And I'm left with 1 over cos x. Doesn't have to be square, I just did. Divided by 1 over sine x. Now,
Oh, it equals 10.
oh, you're ruining lives. One. Anyways, so we have a full fraction divided by a full fraction currently, correct? So now I can actually flip. So I get 1 over cos x times sine x over 1, which if you didn't hear already, is tan. Because it's 1 times sine, which is sine, over 1 times cos, which is cos. Boom. Try the try. Cotan is cos x over sine x. And we're going to multiply that by sine x over 1. Good answer. And then I have a sign on the bottom and a sign on the top by themselves. So what do I get? Cos. All right, what about this one? I have no wait. Let's go. Yeah, okay, I have a wait. What's your question?
When it's multiplication, you don't need common denominator.
Correct. You're correct. When it's multiplication, you should throw a party because they're way easier to do. Okay. What about this one? Who invited you? Okay. We have cos x over sine x, which is cotan, times tan, which is sine x over cos x. And that's my numerator. So I'm going to put in some big brackets. Wow, that was hard to come up with. And then I divide by, shaboom, cosecant, which is 1 over sine. And then the sine and the sine and the cosecant and so. And the green grass grew all around, and the green grass grew. That's what I felt like I was singing. There was a bird in the middle of the nest. So, who invited you? All right, we're back to that again. 1 over sine x. So 1 is actually a fraction. It's 1 over 1, is it not? So full fraction divided by full fraction, it can flip. We get 1 times sine x over 1, which is just sine x, as someone said at the very beginning. So when they're singles, you have no options. You go to the top and you fill them in, right? No options. Well, we have options. We have secant squared x minus 1, which screams Pythagorean theorem identity. Pythagorean theorem identity. Pythagorean theorem, Pythagorean theorem, Pythagorean theorem identity. That's what it thinks.
I'm just says try x.
Yeah, I know. You have to fix that. That's not good.
I just put x equals 0.
So we have the formula 1 plus tan squared theta equals secant squared theta. Whenever you have one with a 1, think Pythagorean theorem identity. Okay. I need it to be secant squared x minus 1, so I'm going to take my theorem, which I should write on the smartboard if someone's actually doing one of those. I have 1 plus tan squared theta equals secant squared theta, and then I subtract 1, so I get tan squared theta.
Yo, hold on.
Yeah.
So where's the 1 plus 10 theta squared theta equals secant on that thing?
It's below the sine and the cos.
Oh, yeah.
There are 3 Pythagorean theorem identities.
I got you.
Right about here. This general formula. Right here. If there's one with a 1, it's coming from the Pythagorean theorem identity. This here is off of your formula sheet. We just talked about them yesterday. I need secant squared x minus 1. So I'm going to subtract 1 like I did here and here, and then I rearrange the formula into that. So this, I can toss it behind my head and say, no thank you. and replace it with tan squared x. And then the rest just stays the same. Cotan squared x. I'm going to change it all in a second. Sine x. So whenever you have a squared with a 1, an adding 1 or a subtracting 1, Pythagorean theorem identity. Pythagorean theorem identity. You got to go to one of the three. Because if you can do that, the rest is not hard. Tan squared x is what?
Sine x squared
Sine-
over cos x.
Yeah, sine squared x over cos squared x. Cotan squared x is cos squared x over sine squared x. And then sine x is just sine x over 1. Is there any plus or minus sign sitting in here? Nope. So if there's something that matches in the numerator, it matches in the denominator, we can cancel. So, cotan and tan just cancel each other out, which makes sense because they're reciprocal trig identities. So it's sine x.
Let's go.
So, your homework for tonight is page 296. We'll move on to some of the other stuff after. Wow, this one has half the questions crossed off. They just didn't want people doing them. Okay, so page 296. Number 3 and 4. Numbers 5 and 6. I want to draw your attention to 5 and 6. 5 and 6. Are we paying attention? 5 and 6 are verifying questions. We did that yesterday. What's the very first step of verifying? Don't put anything across the equal sign, and what do you do with the x? Plug in your x immediately, right? So that's for 5 and 6, and then you have to also state the non-permissible values, which we did yesterday. And then 3 and 4 are like the little proofs you have up here, the basic. Your textbook, just so you know, is way more basic with the proofs than what you're going to get. So there's way more proofs in your notes. Okay? So tomorrow we're finishing off the rest of the proofs in this section, and then we move on to giving you a little bit of a break from proofs. We're going to move on to these. The double angle identities and the subtraction and addition ones. But we get 2 days to do that, so that's not a big deal.
My brain is fried.
Yeah. I thought this was the day you lived here.
No, it was like, obviously, like this day is okay, but.
You said it was so easy.
Just
That's it.
chemistry is bad.
Greg.
I need that Christmas baker. We do. Oh, my God.
Like,
You know what?
I'm really